Good morning, students. Welcome you all for next generation learning. Today, we are going to see the subject of physics, class 9, chapter number 8, motion. Topics: measuring the rate of motion, numerical problems, example sum 8.1 to 8.4. Look at this image. The last class we discussed about distance and displacement. Here I pointed for A, B, C, D. The object travel from A to B, then B to C. So the actual length covered by an object is called distance. Here A to B 2 meter and B to C 2 meter. So the distance covered by the object is 4 meter. What is meant by the displacement? The shortest distance between initial position to final position is called displacement. So the initial position is A and final position is C. So this is the shortest distance between the initial position to final position. So these things we already discussed in the last class. And we discussed about speed also. What's the definition of the speed? The speed is defined as the distance traveled per unit time. So we can write speed equal to distance by time. The symbol of speed is V and distance is S, time is T. So I written V equal to S by T. And it is a scalar quantity. The SI unit is meter per second because the distance is measured in meter and time is measured in second. So speed V equal to meter per second. And the various terms required to measure rate of motion. One is speed and another one is velocity and third one is acceleration. The last class we discussed about speed. For this class we are going to discuss velocity and acceleration. If you take a speed, the speed contain only the magnitude, so it is scalar quantity. When we measured speed with direction, that gives the term velocity. When the direction of motion of an object is also specified, then the term velocity of the body is defined instead of speed. Are you understand? When the direction of motion of the object is also specified, then the term of the velocity then the term velocity of the body is defined instead of speed. Example, the object travel A to B in east direction, then B to C in south direction. When we measure the distance here, the direction of the object is changed. So instead of speed, we have to calculate velocity here because the direction changed. So from this we can write velocity equal to velocity of an object is defined as the displacement of the body per unit time. Speed means distance by time. Velocity means displacement by time. See, so we can write velocity equal to displacement by time. The displacement is represented by the letter small letter d. So time is a t. So v equal to d by t. See here in this image, the direction of the object is changed continuously. So instead of speed, here the velocity is occurred. So first the object travel 2 meter east, then object travel 2 meter north, south, then west 2 meter west, again 2 meter north. So here I mentioned along with the magnitude, I mentioned direction. The next one, It is a vector quantity because we can uh, we can write the velocity equal to 95 kilometer north. Along with the magnitude, we mentioned direction also. So it is a vector quantity. The SI unit is meter per second because the displacement is also measured in meter and time is measured in second. So the same unit of velocity also meter per second. Velocity of an object can be changed by changing the object speed or direction of motion. When the velocity of the body changed, when the direction of the body changed, the velocity of the body also changed. In case the velocity of the object is changing at a uniform rate, then the average velocity is given by arithmetic mean of initial velocity and final velocity for a given period of time. So, for uniform velocity, how to find the average velocity? The average velocity equal to initial velocity plus final velocity by 2. So that is the average velocity is arithmetic means you have to add mean of initial velocity and final velocity. So see, the average velocity is represented by VAV. The AV represent average velocity and the initial velocity is U and final velocity is V by 2. So the average velocity VAV equal to U plus V by 2. When we have to calculate average velocity, the velocity of an object is changing at uniform rate. When the velocity is uniform velocity, we can find the average velocity equal to initial velocity plus final velocity by 2, where AV is the average velocity, U is the initial velocity and V is the final velocity. So during uniform motion of an object along straight line, the velocity remains constant with time. In case the change in velocity of the object for any time interval of is 0. See here the object traveled 2 meter and here also 2, here also 2. So here also 2. So the object traveled A to B. What is the velocity? Velocity is displacement by time in 1 minute. The object cover A to B in 1 minute. So 2 by 1 equal to 2. Listen. Velocity, you know the formula of the velocity, displacement by time. So here I took only 2 point A to B. This is the direction and 2 meter. It covered 2 meter in 1 second. So if I find the velocity, you know, the 2 meter is the displacement to 2 by time equal to 2. But if you take B to C, here also 2 meter in 1 second. So the velocity remains constant with the time. So this type of velocity is called uniform velocity. When the object when the velocity is a constant, then we can say that this is a uniform velocity. But in non-uniform velocity, velocity varies with the time. It has different values at a different instant and a different point of path. Maybe this is a 2 meter and this is a 4 meter. When we calculate the velocity of this direction and this direction, definitely the velocity of these two will be varying. So this type of velocities are called non-uniform velocity. Are you understand what is the difference between the uniform velocity and non-uniform velocity? When the object cover the displacement is equal, then the velocity is constant velocity. the object cover different displacement at a different instant of time, then the velocity is said to be non-uniform velocity. The next one, acceleration. Maybe the velocity is changed means what will happen? To answer such a question, we have to introduce another physical quantity called acceleration. So it is defined as the change in velocity of an object per unit time. Acceleration equal to change in velocity by time. When the velocity will be changed, the acceleration term occur. So we can write acceleration equal to change in velocity by time. If the velocity of an object change from initial value u to the final value v in time t, then the acceleration a equal to v minus u by t. The initial velocity of the object is u and final velocity of the object is v. Then we can write acceleration equal to v minus u by t. The acceleration is nothing but if you take any vehicle, when we start the vehicle, the speed of the vehicle and velocity of the vehicle is less. But after a particular time, the speed of the vehicle and the velocity of the vehicle is changed. Due to this change in the velocity, the acceleration term is occurred. So we can write the acceleration equal to v minus u by t. The v is the final velocity of the body and u is the initial velocity of the body and time is t. If you take a train, the starting velocity of the train is more, but the final velocity of the train is less. When we applied the brake, the velocity is reduced. And it is also vector quantity because acceleration equal to velocity by time. The velocity is a vector quantity means the acceleration also vector quantity. SI unit is meter per second square. How the meter per second square? See here. V minus U. The V is also measured in meter and U is also measured in meter. So, by second. So, meter square by, not my dear, sorry. The SI unit is meter per second square. How? The acceleration equal to velocity by time. The unit of velocity is meter per second and the time is second. When the second will come here, the second square. So, already meter per second. When will it will come upside, meter per second into 1 by second. Here s by 1 by second. So, m by s squared. So the unit of acceleration is meter per second squared. How we get the meter per second square? Because acceleration equal to change in velocity by time. The change in velocity, the unit of velocity is a meter per second by time equal to second. So when the time will come up, meter per second squared. So what are the type of acceleration? One is uniform acceleration and another one is non-uniform acceleration. If an object travels in a straight line, and its velocity increases or decreases by equal amount in equal interval of time, then the acceleration of the object is said to be uniform. When the velocity of the object is a constant, when the velocity of the object is a constant, then the acceleration is said to be uniform acceleration. Example, A to B, the velocity is 2 meter, and B to C, the velocity is 2 meter. So the velocity of the object is same in equal interval of time. So then the acceleration is said to be uniform acceleration. The motion of freely falling body is an example of uniformly accelerated motion. See here, in 0 meter per second, 10 meter per second, 20 meter per second, 30 meter per second, 40 meter per second, 50 meter per second. They give one velocity. If you take the difference between these two, 10, and this is 10. So the object cover equal distance and equal interval of time. Then this type of acceleration is said to be uniform acceleration. In non-uniform acceleration means the velocity of the object is not constant at interval of time. An object can travel with non-uniform acceleration if the velocity changes at non-uniform rate. If the velocity is changing means then we can say that non-uniform acceleration. Dear students, I hope you understood what is meant by the speed, velocity and acceleration. The speed means we can measure only the distance. Now velocity means along with the distance we have to measure the direction. When we measured speed and distance and direction, we get velocity. When the velocity measured, the acceleration also occurred in that place. The next numerical problems. Take your textbook and open the book page number 101. Take your classwork note and copy the discussing problems. Write the formulas before going to write, solve the numerical problem and write neatly. Till now we learned that speed equal to distance by time. This is the first formula. And average speed equal to total distance traveled by total time. This is the second formula. Velocity equal to displacement by time. This is the third one. The fourth formula, average velocity equal to initial velocity plus final velocity by 2. So we can write VAV equal to U plus V by 2. The fifth one is acceleration equal to change in velocity by time taken. So we can write A equal to V minus U by T. These are the very important formula for solving the numerical problems. One is speed, average speed, velocity, average velocity and acceleration. The first numerical problem. See, an object travels 16 meter in 4 seconds. So, if you take an object, that object traveled 16 meter in 4 seconds. And then 16 meter in 2 seconds. Again it travels 16 meter, but it takes a time 2 seconds. What is the average speed of the object? Listen the solution. You know the formula. Average speed equal to total distance by total time. Distance traveled in 4 seconds, 16 meter. It is given. Distance traveled in 2 seconds, 16 meter. So I written distance traveled in 4 seconds equal to 16 meter. Distance traveled in 2 seconds equal to 16 meter. We have to find average speed. So how to find the average speed? We have to measure total distance and total time. So total distance traveled equal to 16 plus 16 equal to 32 meter. Total time, first 4 seconds, second 2 seconds. So 4 plus 2 equal to 6 second. So here I measured total distance, total distance and total time. So average speed equal to total distance by time. Total distance 32, total time 6. So when I multiplied 32 by 6, I got 5.33. You know the unit? The distance means meter and time means second. So the unit is meter per second. So the average speed of the object is 5.33 meter per second. So what is the meaning of this? The object cover 5.33 meter in 1 second. How much distance it covered in 1 second? The object covered 5.33 meter in 1 second. The next one, the example sum 8.2 in book page number 102. The odometer of a car reads 2000 kilometer at the start of a trip and 2400 kilometer at end of the trip. If the trip took 8 hours, calculate average speed of the car in kilometer per hour and also meter per second. So you know that what is maybe the odometer. The odometer is fixed in the automobiles, in the dashboard of the automobiles. It measures the distance. So odometer is a device which tells about the total distance covered. The initial distance is 2000 kilometer. The final trip of the distance is 2400 kilometer. So the total distance covered equal to final distance minus initial distance. The final distance is 2400 kilometer and the initial distance is 2000. When we subtract 2400 from 2000, we can get 400 kilometer. The total time taken of this trip is 8 hours. So total time taken 8 hours. The next, how to find the average speed? Average speed equal to total distance by total time. The total distance 400, the total time 8. If you divide 400 by 8, I get 50. So here the 400, the distance is a the unit of distance is kilometer, the unit of time is hour. So kilometer per hour. So the calculate the average speed of the car in kilometer per hour is 50 kilometer